Hi students, 22EC 301 Signals and System, RMD Engineering College Autonomous Institution. I am Jagan Babu, Department of EC, Assistant Professor. This is unit number 2, Analysis of Continuous Time Signals. We already discussed the topic. Now I am going to discuss a new topic. That's very important topic, one more topic for the second unit. Once we completed the Laplace transform topic, then we have moved to another one more topic transformations called Fourier transformations. The question is, find Fourier transform of x of t which is equal to e power minus 2t u of t minus 3 into e power minus 3t u of t. This is a given question. We need to find the Fourier transform. Like what we had discussed, the Laplace transform, very important 13 mark, like similar to the Fourier transform. We have very important question, this especially like this kind of question. X of t is equal to e power minus 2t u of t minus 3 into e power minus 3t u of t. It's a university problem. Solution. When Fourier transform is there, you have to use j omega. When Laplace, you have to use this x. Okay. Formula, x of j omega is equal to integral minus infinity to infinity x of t e power minus j omega t dt. This is a prescribed formula for the Fourier transform, which is equal to integral minus infinity e power, substitute for the x of t value, e power minus 2t u of t minus 3 into e power minus 3t u of t into e power minus j omega t dt. Next, the limit to be changed from minus infinity to infinity, because what is my u of t value? U of t value ranges from 0 to infinity. So substitute this 0 to infinity here. When I put 0 to infinity, my u of t becomes 1. My u of t becomes 1. So e power minus 2t e power j omega t into dt. So now this term will shifted here and this term will come here. So 0 to infinity e power minus 2t e power minus j omega t dt, first case, minus 3 into this 3 value, integral 0 to infinity e power minus 3t e power minus j omega t dt. Next case, 0 to infinity e power, take e as it is, common term. What are the common terms? Are t, take outside, remaining is j omega 2. So take minus also common, so j omega plus 2 into t into dt. Minus 3 into again tt is common, take outside, sin also common, minus take outside, so j omega plus 3 into dt. Okay, so this step completed. Next step, we will do the integration. Anything power integrated with the e belongs to e only, divided by the coefficients. So e power minus of j omega plus 2 divided by, with respect to t, the t value is minus of j omega plus 2. So divided by minus of j omega plus 2. Limit is 0 to infinity. Minus 3 into, again, e power minus of j omega plus 3 divided by, same coefficient of the t is nothing but minus of j omega plus 3. Limit is 0 to infinity. So I have used the first case integration, second case integration, keeping the 3 as it is, lower limit to upper limit, lower limit to upper limit. Now substitute lower limit to upper limit value, e power minus, substitute this whole term as infinity, e power minus infinity plus, substitute for 0, anything power 0 of e is belongs to e power 0 equal to 1. So 1 divided by, actually lower limit is minus, minus of minus becomes 1. So 1 divided by j omega plus 2 is here. Lower limit is minus, here one minus is there, both becomes plus. So e power minus infinity plus 1 divided by j omega plus 2. Minus 3 into second term. The whole term substituted, there belongs to e power minus infinity minus lower limit. So e power 0, 1 value divided by minus of minus plus, so j omega plus 3. Next step, this is belongs to 0, 1 divided by j omega plus 2 minus 3 into 0, 1 divided by j omega plus 3. So therefore the final answer is equal to x of j omega is equal to 1 divided by j omega plus 2 minus 3 divided by j omega plus 3. The given problem is, find the Fourier transform of the x of t is equal to e power minus 2t u of t minus 3 into e power minus 3t u of t. From the given question you can directly write the answer, which is nothing but when e power is given like this, the answer belongs to 1 divided by j omega plus 2 minus 3 divided by j omega plus 3. How you got this answer? By help of the Fourier transform formula. Similarly, you can write in the form of the Laplace transform 1 divided by, instead of j omega, the relation is s plus 2 minus 3 divided by s plus 3. Thank you.